Welcome to This Explainer. Today, I'm stepping in as your personal exam coach. We're going to completely conquer those intimidating multi-step show that trigonometric proofs, and we'll do it step by step. Look, if you've ever stared at a chaotic algebraic equation on a test and just felt that immediate wave of panic, well, you're in exactly the right place. We are going to demystify these proofs by showing the actual working, breaking down the exact exam strategies you need, and building your confidence so you can secure top marks. Let's get into it.
Okay, here's our exam prep blueprint. We'll kick things off with the fundamental laws, move right into proving basic angle relationships, and then scale up to mastering those tricky triple angle formulas. After that, we'll hit sum and product transformations and wrap it all up with some advanced exam proofs. Section 1, the fundamental laws. Look, to conquer the exam, we absolutely have to start by equipping our mathematical toolbox with the basics. You can't build a house without a solid foundation, and you definitely can't solve a trig proof without these. So these addition and subtraction laws for sine, cosine, and tangent, they are literally your master keys for almost every proof you're going to encounter. Notice carefully how sine keeps the same operator sign. Basically, if you're adding angles, you add the terms. But cosine? Cosine famously flips it. If it's cosine of alpha plus beta, the formula actually subtracts the terms. Let me tell you, forgetting that sign flip is the #1 place students drop easy marks on exams. Don't let that be you. Now, what's super interesting here is that the cosine double angle gives you 3 completely different substitution options. When you see cosine of 2 theta on an exam, you've got a choice to make. You can turn it into cos squared minus sine squared, you can make it 2 cos squared minus 1, or 1 minus 2 sine squared. The secret to showing you're working effectively? Just look at the other side of the equation. Like, do you need to cancel out a positive 1? Use the version with a -1. Does the target answer only have signs in it? Go ahead and pick that third option. Let the exam question itself tell you which tool to pull out. Section 2, proving basic angle relationships. Let's see how this all builds by taking those fundamental tools and immediately applying them to our first set of show that proofs. This is exactly where we start picking up actual exam points. All right, here's a classic class activity. We need to show that the left-hand side, cosine of alpha plus beta minus cosine of alpha minus beta, equals the right-hand side, which is -2 sine alpha sine beta. The golden rule of literally any trig proof, and exactly what examiners are looking for in your working, is to always start with the left-hand side and systematically manipulate it until it perfectly mirrors the right-hand side. Never, ever manipulate both sides at once. So the crucial point here is expanding really carefully. First, write out the full expansion for cosine alpha plus beta. Then subtract the full expansion of cosine alpha minus beta. Because of that tricky cosine sine flip we just talked about, the first bracket gets a minus and the second bracket gets a plus. When you distribute that negative sign across that entire second bracket, the cosine terms just perfectly cancel each other out. And what are we left with? Negative sine alpha sine beta minus another sine alpha sine beta. Boom. They combine perfectly to give us -2 sine alpha sine beta. Full marks right there. Let's look at another one. Here's a super common exam question involving a fraction, which honestly can look way trickier than it actually is. We need to prove that sine of alpha plus beta all over cosine alpha times cosine beta is equal to tangent alpha plus tangent beta. Okay, so how do we show our work here? First up, use your fundamental law to expand that top numerator. It becomes sine alpha cosine beta plus cosine alpha sine beta. Now here is the ultimate fraction trick for your exams. Split the numerator. Put the first term over the common denominator plus the second term over the common denominator. In that first fraction, the cosine betas cancel out, leaving sine alpha over cosine alpha, which is just tangent alpha. In the second fraction, the cosine alphas cancel beautifully, leaving sine beta over cosine beta, which gives us tangent beta. So just by expanding the top and splitting the fraction in 2, the whole thing simplifies directly into our target answer. Moving on to Section 3, mastering triple angle formulas. Now that we have the basics firmly locked down, let's step up the difficulty a bit. These are frequent, high-value questions on exams, so you'll want to pay close attention.
Test your ability. That's what the exam paper says. You might actually be asked to prove a triple angle identity entirely from scratch under test conditions. So show that sine of 3 theta equals 3 sine theta minus 4 sine cubed theta. Notice right away that the right-hand side only has single thetas and only sine functions. That right there is a massive clue for how we should structure our working out.
The brilliant trick here? Breaking 3 theta down into 2 theta plus theta. Once you write it as sine of bracket 2 theta plus theta, you just bust out your fundamental addition law. It expands into sine 2 theta cosine theta plus cosine 2 theta sine theta. Now substitute your double angle formulas. For sine 2 theta, put in 2 sine theta cosine theta. For cosine 2 theta, well, remember our clue from the start? We only want sines in our final answer, so definitely choose the 1 minus 2 sine squared theta option. When you distribute everything, the cosines combine to cosine squared, which you can easily swap for 1 minus sine squared. From there, just follow the algebraic breadcrumbs. Expand, collect your like terms, and you're going to land perfectly on 3 sine theta minus 4 sine cubed theta.
And this next one brilliantly illustrates how we can use those exact same fundamental laws to unravel an even more complex fractional proof. Show that sine 3 theta over sine theta minus cosine 3 theta over cosine theta equals exactly 2. I mean, it almost seems magical that this absolute algebraic soup turns into just the number 2, right? But let's show the working and prove it. Here's the deal. Whenever you have two fractions being subtracted, your most reliable exam strategy is to find a common denominator. Cross-multiply to get your numerator, and you'll get sine 3 theta cosine theta minus cosine 3 theta sine beta. Now, does that pattern look familiar? It should. It's actually the sine subtraction law in reverse. That massive numerator collapses so neatly into sine of bracket 3 theta minus theta, which is just sine of 2 theta. So now our whole fraction is just sine 2 theta over sine theta cosine theta. Finally, expand that sine 2 theta into 2 sine theta cosine theta. The top and bottom sines and cosines perfectly cancel out, leaving us with just the number 2.
Section 4, Sum and Product Transformations. For the final major set of tools in our toolbox, we really need to look at transforming sums into products and products into sums. You will absolutely want to memorize this visual cheat sheet for your exam. Notice how adding 2 sines gives you 2 sine cosine, while adding 2 cosines gives you 2 cosine cosine. Converting between sums and products is absolutely essential for simplifying those massive algebraic equations where terms are added together, but you desperately need to multiply them so you can factor and cancel things out. Examiners really love to test these formulas in reverse. They'll ask you to take a product and explicitly express it as a sum. For example, express cosine 4 theta times sine 2 theta as a sum, or cosine 5 theta times cosine 3 theta. To show you're working on these, you just match the product to the corresponding identity on your cheat sheet. You realize that a product of cosine and sine comes from subtracting 2 sines, and a product of 2 cosines comes from adding 2 cosines. Now, listen up. Here is a pro exam tip. Plug in your specific u and v values by always, and I mean always, treating the larger angle as the sum part and the smaller as the difference part. This helps you avoid messy negative angles if you can. Then simply complete the basic arithmetic inside the brackets to output the final sum. Honestly, it is pure plug and chug, provided you've actually memorized the structure.
Section 5, Advanced Exam Proofs. Okay, let's bring all of these tools together for the ultimate final exam challenges. This is exactly where we separate the A grades from the rest of the pack.
Just look at how intimidating this fraction is to a typical exam candidate. Sine 7 theta minus sine 5 theta, all divided by cosine 7 theta plus cosine 5 theta. It looks awful, yet the target we need to hit on the right-hand side is so amazingly simple, just tangent theta. So if we apply our sum to product formulas to the top and bottom simultaneously, the magic really happens. On top, sine minus sine becomes 2, cosine of the sum over 2, sine of the difference over 2. So that gives us 2 cosine 6 theta sine theta. On the bottom, cosine plus cosine becomes 2, cosine of the sum over 2, cosine of the difference over 2. That's 2 cosine 6 theta cosine theta. Do you see it? The top is 2 cosine 6 theta, and the bottom has 2 cosine 6 theta. Those complex terms literally just melt away. Cancel them out, and you are left exactly with sine theta over cosine theta, which, as we know, is our goal, tangent theta.
All right, this right here is the final boss of the examiner. This is a classic heavyweight exam question, a massive string of 4 additions on the left that we need to cleanly transform into a single string of multiplication on the right.
Here is the pro exam strategy you need. You have to pair them up smartly. By strategically grouping the outermost terms, so 7 theta and 1 theta, and the innermost terms, 5 theta and 3 theta, you set yourself up for total success. Why? Well, because 7 plus 1 is 8, and 5 plus 3 is 8. When you apply the sum to product formula to the outer pair, you get 2 cosine 4 theta cosine 3 theta. Apply it to the inner pair, and you get 2 cosine 4 theta cosine theta. Now check this out. Both pairings have a common factor of 2 cosine 4 theta.
Factor that out, and inside your bracket, you're left with cosine 3 theta plus cosine theta. Apply your sum to product formula one last time to that bracket and multiply it all together. We literally conquer the proof methodically, arriving exactly at 4 cosine theta, cosine 2 theta, cosine 4 theta. It really just goes to show that in college algebra, chaotic and frightening equations are very often just simple truths in disguise, just waiting for you to use the right fundamental law to unmask them. So, armed with these step-by-step techniques and working strategies for your exam, what other mathematical masks are waiting for you to uncover? Happy studying, and we'll see you in the next explainer.